So, once again, good afternoon, students. The next, which is very important distribution, is exponential distribution. But before this, if we have completed Poisson's distribution. It's a very important distribution. We have come across examples, and in the last lecture, we have also seen how the formula is there. This Poisson's distribution is a discrete distribution, as you have to remember. Next, we are going to start with the exponential distribution. In this distribution, the exponential distribution arises in connection with Poisson's process. Yes, it is this distribution exponentially. It is connected with Poisson's distribution. So Poisson's process. What is this connection will come across in this exponential distribution, students? So here, a Poisson's distribution is one exhibits, yes, one exhibiting a random arrival pattern in the following sense. So what is this random arrival pattern in the following sense, students? Okay, we see a small time interval delta t, a small time interval delta t. The probability of an arrival during delta t is, so whatever this arrival time we have taken here, it is alpha delta t, students. Okay, this is alpha delta t. This is yellow means it's gone only. We don't want, okay, let it be like this, alpha delta t, where we can see alpha is nothing but the mean arrival rate. Therefore, we take this alpha delta t as our probability in the exponential distribution. The probability of more than one arrival during delta t is negligible. So you can see, already seen in the last example, that is, I think you come across the cinema queue. Yes, suppose the cinema starts from 12 to and it will end at 3, so it is between 12 to 3. So at 11:30 the queue starts, so therefore all the time we are going to consume for 30 minutes in the queue. So after 12, those who will come in the queue, that time will be negligible, because however it is going to end at 3 p.m. only. Therefore, it is negligible. So whatever the extra time, it is not included. Okay, then it is this exponential distribution. Inter-arrival time are independent of each other. Yes, definitely. In the queue also can see the arrival time will depends on the situation. Suppose you will be busy, you will have some work, or you want to come on the time, right? So even in the examination, you can see some will come at exactly on time, some will come late, some will be early. So depending on the inter-arrival time are independent of each other. In this exponential distribution, this is a kind of statistic process, one for which events occur in a random fashion. Yes, definitely. Events occur in random fashion. Under this assumption, it can be shown that probability distribution function, that is PDF is not that PDF. This PDF is probability distribution function for the distribution of inter-arrival time is given by which is exponentially distributed. So whatever the distribution of inter-arrival time we have taken, so it is, we get the exponential distribution. The curve will be reversed. That is, if you see the properties of exponential distribution, it can be shown that the number of arrivals during an interval is Poisson's distribution. That is, the arrival time or Poisson's distribution. That is a discrete. But then inter-arrival time are exponential distribution. That is the reverse of this, and it is continuous, students. So please remember, exponential distribution, inter-arrival time are exponentially distributed. And here the mean arrival rate is given by alpha and mean inter-arrival time is given by reverse, that is 1 divided by alpha, student. So please remember, what is the mean of exponential distribution? It is 1 divided by alpha. Alpha is any parameter we are going to take here. The Poisson distribution is a discrete distribution. It is clear that Poisson's distribution is a discrete distribution. Remember this, please. Closely related to the binomial distribution. Yes, we have come across that Poisson's distribution is a related to binomial distribution and will be considered. Already we have considered this. Okay, then it can be shown that for exponential distribution, mean is equal to standard deviation. Yes, you can see the property of exponential distribution. It says that mean is equal to standard deviation, so which is equal to nothing but 1 divided by alpha, student. So exponential distribution is the only continuous distribution that is memoryless, in the sense that, so we have taken here one example probability. I will show you. So here what we have taken, x is greater than a plus b. How we are going to distribute this, students? Yes, definitely x is greater than a and x is also greater than b. Then only we can say a plus b is x is greater than a plus b. So you can see this is continuous, this is also continuous. So we don't have here upper limit. So we take here infinity. That means that it is continuous distribution, students. Okay. So this is what we take the exponential distribution as continuous distribution. So we come across probability density function, students. Yes, this is very, very important. Probability density function for x greater than 0 is, yes, it is f of x is equal to alpha e raised to minus alpha x. Otherwise, it is 0. So whenever x is greater than 0, exponential probability density function is given by f of x is equal to alpha e raised to minus alpha x, student. So just have another applications I have quoted. Just the applications for exponent distribution is a continuous probability distribution. Yes, used to model the time we need to wait before a given event occurs. Yes, this is a continuous distribution and it is a tool used in probability theory statistics. Yes, this distribution is very, very important in statistics also. It is used to test if a statement regarding a population parameter is correct. Yes, very important this statement. Whatever, suppose in the crime case or any cases, you can see even in the your feedback also, you can just see the statement whatever is given, is it correct or wrong. We can go through this exponential distribution. Also useful in hypothesis testing. Yes, very, very important hypothesis testing. We come across the crime scenes, we can see there how the test they are going to conduct here is, whatever the statement they have given, they are going to check this statement is correct or no, and then they will go through the testing this hypothesis by using exponential distribution. So these are all the applications I have just quoted, and then we'll go through the graphical appearance of the exponential distribution. So you can take from x to f of x. This f of x will tell you the curve is exponentially distributed. So this is what we have, the curve of exponential distribution. Okay, students. So this is just a simple introduction of exponential distribution. Now we'll go to what you have to remember, very, very important for you to solve the example. Probability density function. So already I have told you what is probability density function. It is f of x is equal to alpha e raised to minus alpha x for x greater than 0. Please remember this, and 0 otherwise. Then the second you have to remember, mean is equal to standard deviation. So please remember, mean is equal to standard deviation is nothing but mu is equal to sigma is equal to 1 upon alpha. So this means that variance is equal to 1 upon alpha square. So also you have to remember it is continuous probability distribution in the interval 0 and 1. Remember, it is continuous probability distribution in the interval 0 and 1, student. So immediately we'll go with the example, student. You can see here, if x is exponentially variate with mean 3, okay, find p of x greater than 1 and p of x is less than 3 students. So see, you can just identify what is given here, student. Okay. So in the solution, what we come across, they have told they have given mean. So what is mean, student? It is 3. I will take mean, no problem. Mean is equal to 3. But we know already what is mean. Mean is nothing but, student, it is 1 upon alpha. So 1 upon alpha is nothing but 3. That implies alpha is nothing but reverse this. It is 1 divided by 3, students. So remember the formula now immediately, exponential distribution formula. So when it is x is greater than 0, yes, definitely this is x is greater than 0. So both are x is greater than 0. Therefore, we take here the function f of x. You have to remember the formula from alpha e raised to minus alpha x, and x is between x is greater than 0 and less than infinity. Definitely remember this, students. Then next it is, otherwise it is 0. Okay, then next will come after writing the formula. This is all given before starting the example. You should remember this many things. Then you can see, we'll take the probability function. Now we'll substitute first alpha is equal to 1 upon 3. Therefore, f of x is equal to integration 1 upon 3 e raised to minus x upon 3. What I have done here, student, I have just substituted alpha value, that is 1 upon 3, students. Okay. Then we'll simplify this further. We'll take the first one now, that is probability of x less than 1. So already I have told you, if it is the upper limit is greater than 0 means you have to reverse this. How you will reverse? Already you wrote in the last example we have done this. P plus q is equal to 1. So q is equal to 1 minus p. So we'll reverse this. So what we get, because it must be in the interval like this, but we see this upper limit is going beyond the integration, therefore it is infinity. So therefore we take 1 minus p of x is less than equal to 1. So when p of x is less than equal to 1, this is equal to, you get this as 1 minus. So by using the, because this distribution is a continuous distribution, so I think you should remember the continuous distribution formula. Consider continuous distribution says from integration minus infinity to infinity f of x dx. So here what we have, students, lower limit they have not given, but you have to remember in the exponential, lower limit will be 0. So this is x and this is less than equal to 1. Therefore, we take the integration from 0 to 1 f of x dx, student. So this, like this you have to remember the function. Now substitute the values, student. So this is 1 minus integration 0 to 1. F of x dx is between, it will come as a positive value. If it is negative, we take it as otherwise 0. So this is f of x is equal to nothing but 1 upon 3 e raised to minus x divided by 3, student. So please substitute in the calculator and tell me what is the answer, student. No need to calculate using the formula. You can go through directly using the calculator. Please substitute in the calculator and tell me. Yes. Yes, I think Muzammil is there. Rahul, Raj, please substitute in the calculator and tell me what is the answer.
Muzamil is in B division.
Oh, sorry, sorry. Okay, I think Furkan is there. So substitute the values and tell me. Yes, Raj, what did you got the answer? Yes, who has got the answer? Please tell me. Just substitute here 1 minus integration 0 to 1, 1 upon 3, e raised to minus x upon 3. I think you are expert in calculators now. Yes, Uma, what you did you got the answer? Yes, please repeat once again. 0 point
So point 716.
716. Yes, very good. So I think everyone got the same answer. Just check once again, Rahul and Raj. Did you got the same answer? It is 0.716. Yes, please check once again. Everyone got the same answer, 0.716.
Yes, sir.
Okay, so we'll go with the second one. Fine. So like this you should solve. So when it is p of x is greater than 1, we get the probability 0.716. I go to the second one. Second one, it says p of x, probability of x greater than 3 students. So means that you have to always remember lower limit 0, and this will be limit from 0 to 3. Therefore, what we get the integration? Integration 0 to 3. So upper limit is fixed, means we can simplify very easily. That is f of x dx, students. So substitute the values and tell me the answer, student, please fast. Integration 0 to 3. F of x is what, student? It is 1 upon 3 e raised to minus x upon 3 dx, student. So substitute the values and tell me the answer. Directly you will get the answer. Yes, Priyanka, you got the answer. Please substitute in your calculator. Just simple calculation, integration 0 to 3, 1 upon 3 e raised to minus x divided by 3 into dx.
So point 367.
Yes, you got the 0.367. Everyone got the same thing. Please check once again. Just you have substituted the values correctly or no. Please check once again.
Sir, it should be 1 minus integration of 0 to 3.
1 minus integration. See, if it is here what we have done, I will show you, wait. Because
Sir, the answer is wrong.
answer
Then,
is wrong.
sir, I did 1 minus.
Hey, how it is 1 minus c? There is no 1 minus, no beta, see here. This is infinity. Greater upper limit is sorry. Upper
Sir,
limit is
answer is
infinity.
0.632.
Yes, answer is correct. It is 0.632 is correct answer. So I will just change the answer first. 0. I will tell you why. 0.6321 is the correct answer. Very good. Because here what happens, upper limit is infinity, and upper limit is infinity means we cannot simplify. Therefore, if you reverse this, what happens? It will be like this: 0 less than x less than 1, because lower limit will never cross 0. So lower limit will be 0. Only when they have mentioned, then it will cross. But here they have not mentioned. Therefore, you want to reverse this, it will 0 to 1. But here upper limit is fixed. You cannot take infinity here because they have already fixed it as 3. If they give infinity, upper limit infinity, then we have to reverse this. Then it will be 1 minus 0 to 1 f of x dx. Okay. So I think everyone got 0.6321.
Yes, sir.
Yes. Okay.
Yes,
So
sir.
we'll go with the next example. Yes. So you can write down the next example, student. Example 2. So this is our example 2. Why this is yes. So you can take down the example 2. Okay. Is example 2 visible, students? Yes. So in example
Excuse
2,
me,
we
sir.
can see. Yes, please tell me.
Sir, can
What
you
is it?
repeat the previous one?
Okay. See here, if x is an exponential variate with mean 3, find p of x
Raj.
greater. Yes, p of x greater than 1 and p of x is less than 3. Means mean you have taken 3, means alpha you must take 1 upon alpha, 1 upon 3, sorry. Then the function, you have to remember this formula for exponential distribution. Substitute here 1 upon 3, you will get this. And then they have told you to calculate here p of x, p of x less than 1. So upper limit will be infinity. So I want to reverse this. Therefore, it will be like this. If you reverse this, what will happen? Infinity less than x less than 1. But this is not true because we cannot take less than 1 infinity. Therefore, we consider this as 0. So this is just an idea that 0 is less than x less than 1. So if you want to reverse this function, you have to go to p plus q is equal to 1. So when you reverse this function, you will get here, already I have told you, I think. This is q is equal to 1 minus p. This is applicable only when you reverse the function. Therefore, we get the
Yes, sir.
lower
Understood.
limit 0 less than x less than 1. But
Yes,
here
sir.
what is the problem? There is no problem only because already it is x is less than 3, means in the exponential distribution will start from 0 to 1, but here upper limit mentioned it is 3. Obviously you have to take here 0 to 3 integration.
Yes,
Okay,
sir.
fine. So now we'll go for next example, example 2, students. So you can please try this now. I will tell you how to simplify this example. In a certain town, duration of a shower is exponentially distribution with mean 5 minutes. What is the probability that a shower will last for? Okay, so then you have seen shower, I think everybody showers, right? You will be clean and you'll be ready for the classes. Yes, I think, yes, you should every day you should be clean and ready for the classes. You should go for bath. So in a town they go for shower. So there we see exponential distribution. See, so many examples we have done. We have taken here exponential distribution. So how it is useful you can see now. So in this, they have taken with mean 5 minutes. Means what is now PDF? That is probability, probability distribution function. You can see probability distribution function of exponential exponential distribution is. So how this is distributed, you can see by taking mean 5 minutes. So remember, whenever if you take mean as 5 minutes, means 1 upon alpha is equal to 5 or alpha is equal to 1 upon 5. This is what you have to remember. And the function I will take, because this is a function greater than x is greater than 0, you can see 10 is greater than 0. Here it is again greater than 0. 10 to 12 is also greater than 0. So I will fix the formula now. It is alpha e raised to minus alpha x. I think you remember x is greater than 0. For x is greater than 0, we get the exponential distribution function as f of x is equal to alpha e raised to minus alpha x. And you should remember that they have told that mean is equal to 5 minutes. So what mean, it is 1 upon alpha is equal to 5. That means that alpha is equal to 1 upon 5, students. So substitute now in this formula. Therefore, what we get, f of x is equal to, it is 1 upon 5 e raised to minus x upon 5. This is what everything this is given in this question, students. Okay, so now we will start the first one. What you want to find Yes, you want to find that in the first one they are told 10 or more, 10 minutes or more means 10x is equal to 10 or our random variable x is more greater than 10 means probability you are going to find for x is greater than equal to 10 students. So this is x is greater than equal to 10 means they have already told you the limit. Otherwise, you can just go for simplification from the previous example. You can do that. So I will show you instead of reversing this, you can also simplify directly. So this is 10. In the reverse, what happens? You are going to take lower limit 10. So it means this is less than equal to 10 means definitely here nothing is given means you have to understand it is infinity student. So you can also try to simplify like this also. I think you may, if you are getting confused, then you can substitute here. This is f of x. Wait, I'll substitute first f of x dx. Even you can solve like this one. So I'm going to solve like this only now. So it is 1 upon 5 e raised to minus x upon 5 dx. But you remember that in the calculator, I think you cannot substitute this value. Yes, so what you have to do, simplify step by step. These steps are increased here. So what we get here, 1 upon 5 is constant, so I'll write 1 upon 5 outside. Integration, okay, you have to remember the formula of integration. Yes, it is integration e raised to ax dx, which is equal to integration ax divided by a. Here a, you have to take minus 1 upon 5 from this, and x remains as it is, so it is minus. So what will be the integration of e raised to minus x upon 5? It is e raised to minus x upon 5 divided by minus 1 upon 5 integration from 10 to infinity students. So you can see 1 upon 5 in the numerator and 1 upon 5 in the denominator will get cancelled. Here it is plus into minus I will do. I am going to get here minus, then I will substitute first infinity. So you remember e raised to minus x upon 5 minus, that is integration. If it is f of x is given from a to b, you should note the formula. This is equal to f of b minus f of a. So I will substitute first upper limit infinity. So e raised to, you can take this as e raised to minus x upon 5 means x is infinity. So it is e raised to minus infinity upon 5 means again it will be infinity only. So I think e raised to infinity you should know that it is always 0 only. So remember this please, e raised to infinity is 0. Then minus e raised to, it is minus x is 10. So 10 upon 5. This is what you have to simplify if you don't reverse the example. In like this fashion also you can simplify this example. So this is minus 0 as it is minus e raised to minus 10 upon 5. Minus 10 upon 5 is nothing but minus 2 students. So please tell me minus into minus plus e raised to minus 2. What is the value for e raised to minus 2 students? Directly you can calculate in the calculator, and please tell me what is the answer for e raised to minus 2.
0.1353.
Yes, very good. The answer is correct. Excellent. 0.1353 is the correct answer, student. So like this, you can calculate the probability. Okay, next we'll go with the second one. What it says, less than 10 minutes means it is clearly mentioned that x is less than 10. Random variable x is less than 10. Okay, find the probability now, students. Start solving. Don't wait for me now. You understood how to simplify this. So second one I will tell you. We're going to take second one. Probability x less than 10. Lower limit they have given, student. Okay, upper limit they have given 10, student. So lower limit already you know in
Sir,
exponential
upper
distribution.
sir,
Yes,
upper limit
yes.
should be 9, right?
नहीं नहीं नहीं, they have given between, no. So integration is continuous function, it will be from 0 to 10. So I'm going to take here,
Sir, but it is given less than 10, not less than or equal to.
yes, it is not closed interval, here we have to take open interval. So continuous function You have to take upper limit and lower limit. It is just a limit, sorry. It is an upper limit and lower limit. So we take upper limit and lower limit 0 to 10. In discrete, we have to take here less than 10, that is 9. You should take 9 for discrete. For continuous, is an open interval 0 to 10. Yes, please remember, very important question. Whenever x is less than 10, for continuous function you have to take here upper limit 10. For discrete function you have to take 9. It is less than 10. Is it clear now? Okay. So integration 0 to 10 we have, and then we have function f of x dx, which is equal to, simplify the values from 0 to 10. F of x will become 1 upon 5 e raised to minus x upon 5 dx, student. Because this is a continuous function, therefore we have to include x less than 10. That is 10 you have to include, students. Only for continuous function this is applicable. So this is equal to, okay, substitute this value directly in your calculator. Yes, please tell me what is the answer now. Yes, please, what we got the integration answer? Integration of 0 to 10, 1 upon 5 e raised to minus x divided by 5 into dx. Fix this formula, student, then you can put the values directly. Don't change the formula in the calculator. Yes, what you get the answer, student?
So 0.864.
Yes, very good. It is, the answer is correct. 0.8647, I think you will get. So it is a probability of x less than 10. For exponential distribution, we get the probability 0.8647. So please check once again. Everyone, check your answers. Okay. Till then, we go for the third one. So x is between 10 and 12 minutes, means you can directly identify our random variable is between 10 and 12. So upper limit 12 and lower limit 10, because it is continuous function. You have to include 10 and 12. For discrete functions, we don't include. Yes, very good. So third one, p of 10 less than x less than 12, students. So I think you should remember now. You should calculate and tell me. It is integration from 10 to 12 f of x dx. As it is a positive value, therefore the function will be.
Excuse me, sir.
Yes, tell me please.
So how do we know that 12 is the upper limit?
They have given here, see, between 10 and 12 minutes. Clearly mentioned, between 10 and 12 minutes. Is it any doubt? Still you have
No,
any
sir.
doubt? Okay.
No, sir, got it.
Uh, if they have given, then only we can take. Yes, very good. If they have not given, you cannot take directly like that. So whatever the question is there, you have to understand very carefully. Okay, so this is equal to, I think you can directly substitute in your calculator. Therefore, we get the probability 10 less than x less than 12. We get the answer. Yes, put in the calculator integration 10 to 12, 1 divided by 5 e raised to minus x divided by 5 dx. What we get the answer, students?
0.04461.
Yes, very good. I think everybody got the answer. 0.0.
4461.
Yes, 4467 is the correct answer. I think everyone got the answer, students. So like this, you have to calculate the probability over exponential distribution, student. Okay, so we'll go with now. I'll repeat this once again. So you can see in the example 2. In a certain town, duration of shower is exponentially distributed. Means you have to use the exponential distribution formula here. It's very clear. With mean 5 minutes, what is the probability that shower will last for 10 minutes or more? Okay, this is first one. Second one, less than 10 minutes. Or in the third one, they have told between 10 and 12 minutes. So this is what they have given. X is equal to, you will take here 10, or X is equal to greater than 10. Therefore, X is, you should remember, X is greater than equal to 10 by using this statement. Then less than 10 minutes, X is less than 10. Between 10 and 12 minutes means X is between 10 and 12. So this will be the integration here. So accordingly, you'll get the integration. That is, in the first one, you can see upper limit they have not given, so you have to consider infinity. Otherwise, you have to reverse this. So I think you will get like this somewhat: 0, x, and this is 10. If you reverse, then you can see 1 minus integration 0 to 10 f of x dx. You can do this if you reverse, but not necessary. We have done both the ways. We get the correct answer. Okay, so what we get here, this is equal to integration 10 to infinity f of x dx. If you simplify, you will get this as 0.1353 students. Next, you can see in the second case, what they have told, less than 10 minutes means the random variable you have to choose x is less than 10. You can have chosen x is less than 10, means the lower limit will be 0. In exponential distribution already we have discussed. The lower limit, if they are not mentioned, you have to consider this as 0 only. So integration 0 to 10 f of x dx is equal to, substitute the values, we get the probability 0.8647 students. So in the next case, you can see in the third case, what they have said, between 10 and 12 minutes. So see, so much time is required to shower. No. Okay. So probability of between 10 is less than x is less than 12, which is equal to integration 10 to 12 f of x dx. If we substitute the values, we get this probability is equal to 0.04467. So this is how you should able to solve the examples, and